This is Geometry Unit 8, Day 5 homework. This is the second day that we're working with page 702. We're writing equations of a circle. So here we know that the center is 0, 0, and on the circle there's a point. So the center is always your HK, and a point that's on the circle would be your XY. If you make a small sketch with the center at the origin and 0, 6 on the circle, we know that the radius is going to be 6. We don't have to do much other calculations than that. Since it's a vertical measurement, we can see that that would be 6. So we would get x minus 0. Let's see, x minus h squared plus y minus k squared equals r squared. That's your basic formula, your standard formula of a circle. So x minus 0 gives you x squared. Y minus 0 would give you y squared. And your radius squared would give you 36. Here, we'll make a quick sketch. We have a center point at 1, 2. We have another point that's at 4, 2. So this one is horizontal from the center to the point on the circle. So again, we can count that. That's a radius of 3. So if it has a radius of 3, then we don't have to worry about another way to figure out the radius. We can see, because it's horizontal, the y values are the same, so the x values are how far you got to determine that you're going. So we're going to say x minus h squared plus y minus k squared equals r squared. We know the radius is 3. We know our h and the k. So we're going to say x minus 1 quantity squared and y minus 2 quantity squared equals 9. Now notice how this one's different. They give you the point of negative 3, 5, and they also give you a point 1, 8. We know that vertically we don't know that distance, and horizontally we don't know that distance. The point is slanted, so we can't figure out the radius quite yet. We could use a distance formula, or we could use our basic formula called the standard formula for a circle. Our center will be the HK, and the other point is your XY. So because it's a slanted measurement, a slanted radius, I can't count it horizontally or vertically. I'm going to take my x minus my h and my y minus my k, and we're going to solve for the r. So this becomes 1 plus 3, and this becomes 8 minus 5, which is 3. This is 4 squared, which is 16. This is 9 squared, or 3 squared, which is 9. So we get 25 for the r squared. So to write our equation, we're going to say x plus 3, because it's minus a negative for the h, y minus 5 quantity squared equals 25. For number 20, we're going to graph the equation. we see that we have x squared plus y squared equals 49. So that's telling you that our center is going to be at 0, 0. And our radius squared equals 49, so the radius is going to be 7. So for a radius of 7, I'm going to use a different scale. I'm going to go by 2's. So this is going to be 2 up, and this is going to be 2 to the side. So we'll go 2, 4, 6, 7 to the side, 2, 4, 6, 7 to the side, up, 2, 4, 6, 7, and 2, 4, 6, 7. So there's our equation. Here we have a center at 3, 0. R squared equals 16, so the radius is going to be 4. So 3, 0 is our center. Our radius is 4. So 4 to the right, 4 up, 4 to the left, and 4 down. So there's our circle with a center at 3, 0 and a radius of 4. Number 22 has a center at 0, -2, and the R is going to be 6. 0, -2, going to be overlapping there a little bit. So those are my different circles given the equation graphed on graph paper. For number 23, we're going to find the center, and the center is at 4, 1, and the radius squared equals 1, so the radius is going to equal 1. So a positive 4, positive 1 for your center. Then you go 1 unit to the right, up, left, and down. Here we have a center at -5, 3. And the radius squared equals 9, so the radius is the square root of 9, which is 3. So we're going to go 5 to the left, 3 up, and we'll have a radius of 3. This last one has a center at -2, -6. Has a radius of 5. R squared is 25, so the radius is 5. this scale, notice that each bar is going by 2 in this case, and going down by 2s. So when I go to the left and 6 down, we're going to go to the left and 2, 4, 6 on the way down. Then we'll have a radius of 5. 2, 4, 5, 2, 4, 5. 5 will be halfway between 4 and 6. 2, 4, 5. 1, 2, 3, 4, 5. For number 36, we're talking about a word problem that has to do with commuter trains, and we have zone 1 that has a 3-mile radius. So from the center of the city, we do 3 miles in every direction. So zone 1 would fall within this circle. Zone 2 would be within that 3 miles up to 7, so we're looking for a radius of 7. So this middle portion in between these two circles would be considered zone number 2. Anything outside that zone, outside that donut shape, would be considered zone number 3. Now what we're looking for is to find which zone the people live at. So if we're at 3 over and 4 up, 3 comma 4, that's in zone 2. Six comma 5, on my picture, that's looking like it's outside. For 6 comma 5, we would be in zone 3 because we're outside the circle. Then we'd have 1 comma 2. That's in zone 1. 0 comma 3. You're right on the edge. We would still call that zone 1. And then 1 comma 6. That would be obviously in zone number 2. A CD has a diameter of 4.8 inches. The diameter of the center hole of a CD is 0.6 inches. We're supposed to write the equation of the circle that represents the CD and then represents the hole of the CD. So when we write a equation of a circle, we need to know a center, which we're going to call 0, 0, and we need to know the radius. So if the diameter is 4.8, we're going to divide that by 2 to figure out the radius. So we're going to get 2.4. And when we square that, we get 2.4 squared, so we're going to get 5.76. So our equation is going to be x squared plus y squared equals 5.76. And then when we have the whole of the CD, it has a radius of 0.6, or has a diameter of 0.6, so we have to divide that by 2 to figure out the radius, so that's going to come up to be 0.3. And when you square 0.3, that's going to be 0.3 times 0.3, which is 0.9, but you move the decimal spot over 2, so it's actually 0.09. So now we have x squared plus y squared equals 0.09. Those are the equations of the circles that represent a CD, the outer edge and also the inner circle of a CD. Last problem. I'll put it together right here. For number 42, we have these cell phone towers, and they're located throughout the city. The first spot one is located at is at 0, 0, and it has a range of 3. We have another cell phone tower located at 0, 5. 0 right and left, with a radius of 3. And then our last cell phone tower is at 6, 3. And it has a radius of 3. So those are our towers. Now what we're supposed to look at is, are there any areas that may receive calls from more than one tower? And that would be this portion right in here. That anyone living inside that location would receive calls from both towers. Small area from both towers. Suppose your home is located at 2, 6 and your school is at 2.53. Can you use your cell phone at either or both of these locations? So 2, 6. That's your home. So yes, we can use our cell phone there because we're right in that circle. 2.5, 3. Right there, that's a hard call. Maybe we're right on the edge. Maybe you can use it. I put my dot, it looks like, outside that circle, so that would be pretty close. the home could use the cell phone, but school is on the very edge. Since we're just drawing it by hand, it's a little hard to tell if we would be right on that or not. Last question. This city is located, or city A is located at -2, 2.5. And city B is at 5, 4. That's city B, that's city A. Each has a radius of 1.5. Which city seems to have better cell phone coverage? Well, it looks like here city B is inside this circle, but city A has a lot of area that is outside the two cell phone coverages. City A is outside the phone coverage, or parts of city A. Are outside the cell phone coverage. All of city B is in the phone coverage.